All right, so graphing inequalities in two variables. When we did it with one variable before, if you remember when we graphed something like x is greater than or equal to 7, we graphed that on the number line. And that was like 0 and 7. Greater than or equal to was a solid dot, and then you followed the direction of what the problem was talking about. So greater than or equal to 7, that would be to the right, something like that. Well, when we're in two variables, it's going to be very similar, except we're going to do it on the coordinate plane. Instead of just one-dimensional like this, it's going to be in 2 dimensions on the coordinate plane. Now, for greater than or equal to or less than or equal to, back then we used a solid dot. When we're graphing a line, we're going to make it a solid line. If we have greater than or less than, that is going to be, it's not going to be a solid line like this. It's going to be a dashed line or a dashed line. So, for example, something like that. Right? We'll talk about why in just a minute, but those are the nuts and bolts you need to know for right now. Greater than or equal to, less than or equal to a solid line, less than or greater than is going to be a dashed line. Again, so let's get to our first example. Y is greater than or equal to negative 2/3 x plus 1. This is going to be our first example here. Now, this is in y almost equals mx plus b. Right? So you're just going to graph this the way we always do. M is equal to negative 2/3 x. Or m is 2/3 rather, negative 2/3. And b is the point 0, 1. So you'll need some graph paper, or you'll need to sketch your own graph through the magic of technology. I'm going to put mine there. And we're just going to graph this just like we always have. B is 0, 1. Slope is negative 2/3, so down 2, right 3, down 2, right 3. If we go up to right 3, up to right 3. Then get a straight edge and draw your line. Now, because this is greater than or equal to, this is going to be a solid line. This is a solid line. Alright, now, the reason why it's solid is because any point that's on this line, for example, 6, negative 3, is a solution to this inequality right here. For example, 6, negative 3, y is 6, so 6, negative 2/3 times 6 would be negative 4, plus 1 is negative 3. Since y is negative 3 is greater than or equal to negative 3, so that's why the point 6, negative 3 is a solution, because it gives us a true statement. Points that are on the line gives us a true statement. But there are other points that are also a solution to this. One point that we're going to test to see if it is a solution is the point 0, 0. And this is what I like to call our test point. TP. It's not toilet paper, it's test point. Our test point here is going to be 0, 0. If I plug 0, 0 into the original function, I'll get 0 is greater than or equal to negative 2/3 times 0 is 0, plus 1 is 1. So, when I plug 0, 0 into our original equation, we get 0 is greater than or equal to 1. Is that true? No, that is not true. That is false. So, since that is false, 0, 0 is not a point on our line. Alright, so, in fact, instead of that, 0, 0 is not a point on our line, so he is very sad and upset. But here's the thing, every other point on the other side of the line is a solution. So we're going to shade in all of these points here. All of these are solutions. Everything up here is a solution. So for example, the point 2, 7. That's a point that's inside this shaded region now. Let me show you that 2, 7 is indeed a solution. If we were to plug 2, 7 into the equation here, we would have 7 is greater than or equal to negative 2 times negative 2/3 times 2, our x-coordinate, is negative 4/3 plus 1. So this would be 7 is greater than or equal to negative 1/3. Is that a true statement? Yes. Any point on the other side of this line are solutions to this inequality. It's not enough just to draw a line anymore. We have to say all the points that are true, and that's all these above the line. So again, we use the test point to see if 0, 0 was a solution. Since it wasn't, we shaded the other side. All right, let's do a second example here. Example 2. 3x minus 4y is less than 8. Is less than 8. I'll get my grid ready. Paste it there. So here's the thing. I know since this is kind of in a pseudo standard form, I like doing the intercepts. But just to review some stuff about inequalities and whatnot, let's solve for y. So if we were to solve for y, the first thing we do is subtract 3x from both sides. We'd be left with negative 4x, purple, less than 8 minus 3x. Then we would divide by negative 4 on both sides. So we'd be left with, oh my goodness, I'm sorry, y'all. Let me go back here. This is negative 4y, right? You had that. I made a mistake. My bad. Divide by negative 4 on both sides still. So now we would have y is, now here's the thing. Since we divided by negative 4, we would flip the symbol. 8 divided by negative 4 is negative 2. Negative 3 divided by negative 4 is positive 3/4 x. Alright, so now this is in pseudo slope-intercept form. M is 3/4. Our y-intercept is the point 0, negative 2. So let's plot that point. 0, negative 2. Our slope is 3/4. Up 3, right 4. Or we could go down 3, left 4. And those are points that are on our line. However, remember, since we're using this equation here, look at our inequality. It says it's greater than, not equal to. Since it's greater than, we're just going to put a dashed line. Put a dashed line to represent this graph. A dashed line. Now, why is it dashed, Smith? So here's the thing. If you took the point 8, 4, for example, and plugged that in, let's plug it into the original equation. If I plugged in 8, 4, I would get 3 times 3 times 8 is 24, minus 4 times 4 is 16. Is that less than 8? 24 minus 16 is 8. Is 8 less than 8? No, it is not. So all the points on this line are not a solution to this function, or to this graph. So that's why it's dashed. We're saying we're not including the points that are on the line. But there are other points that make this true. Let's use our test point. Our test point, always pick an easy test point. In this case, again, I'm going to go with 0, 0. 0, 0 is easy because if you plug in 0, 0 to x and y, you get 0 minus 0 is 0. Is 0 less than 8? Indeed it is. That is true. So it's a happy test point. So that means that 0, 0 is a solution. In fact, everything on the side of the 0, 0 side of the line is a solution. Any one of these points is. On the other side of the line, it's not a solution. All right, so I showed you why we have a dashed line for less than or greater than. And then we did an example of a test point on either side of the line. If it's true, you shade the side of the line that the test point is on. If it is untrue, like it was in example 1, 0, 0 was not true, so we shaded the other side of the line. All right, so let's do one more, just to make sure that we got this. Y is less than or equal to 2x plus 4. Do it. Press pause, graph that, and then check your answer. All right, let's check your answer. Here I got m is 2, b is the point 0, 4. So 0, 4 with a slope of 2. Is this a solid line or a dashed line? This is a solid line. Then I'm going to use my test point. My test point I'm going to use again is 0, 0. Is 0, 0 a solution? Is 0 less than or equal to 4? Yes! So I'm going to shade the side that 0, 0 is on, so that means that everything here is a solution. Awesome. So that's what our graph should look like. It's a straight line like this, but then we're going to shade below the line to indicate that all of these points are solutions. So my next question to you is, this graph here, is this graph a function? If you'd like to talk about that in class tomorrow, ask me a question. Otherwise, just something for you to chew on. Spit out!